Welcome back. Today we're going to be looking at bitwise operators in Python. So what are bitwise operators? Well, basically they act on bits, which are the ones and zeros that make up all the data types in Python. Usually you would write numbers as numbers, but if they've got a binary representation, then there's some cool stuff that you can do with them. So if you were to AND two numbers together, you can see we've got a truth table in the bottom. Each of these bits gets ANDed, and you can see with AND it only becomes a 1 when the two previous bits are a 1. With OR it's slightly different. It's only a 0 when the two previous bits are a 0, and that's a pipe, which is a bit harder to remember than the ampersand for AND. Then there's the XOR, which basically checks that their one's a 1 and one's a 0. So you see 0, 0, 0, 1, 0, 1, 1, 1, 0, and 0, 1, 1. And then there's the NOT. The NOT only works on one number rather than the XOR and OR. And you can see it's just inverted all of the bits. So each 1 becomes a 0 and each 0 becomes a 1. You can also do shifts. So with a shift, it takes a number and it moves it in a certain direction. If we start with the right shift, you can see that it's moved everything 2 places to the right. And you'll notice with the right shift, it's actually cut off these 2 bits, which you might want, you might not. I mean, if you're floor dividing by 4, then you wouldn't want the last 2 bits. But with the left shift, you can see in this example I've got it to cut off the top bit, but it doesn't always have to. Sometimes it will, sometimes it won't, but usually in Python it doesn't. And so you're probably wondering, these are great, but what's the use of them? So to start, I've just written a couple of numbers in binary. You can see this is 255 in binary, and because it starts with OB, that says it's in binary. And that's the number 1 in binary. If you want to convert back to binary, you can either use this bin function, or you can use this special format string, where you go O and then B to say in binary, and then you put the number in. Although we'll write a slightly better version of the bin at the end. One of the most useful things you can do with bitwise operators is powers, because you can either raise something to the power 2, which is a lot slower than here, where you just shift it to the left 2 bits. And you can imagine that as 1 is 2 to the 0, and if you shift it once, you get 2 to the 1, then 2 to the 2, and so on. So that's why this works. You can also do other stuff, so this doubles the number and adds 1, and we've shifted everything to the left 1 bit, which is the same as doubling it, and then we've ORed it with 1. So because the last bit will definitely not be set, because it's now an even number, we've now added that 1 in with the OR. You can see that's worked quite nicely. Another thing is, if you AND bits together, it's only going to be a 1 where both this bit is a 1, where there's only 1, and this bit is a 1. You can see that it only comes out when it's a 4. So then for I in range 4, so we do this 4 times because it's a 4-bit number. We AND it with 1 shifted 2 times, and you can see we get this. This is a function that counts, and you can see that for each time we add 1 if it's got that 1 there, because for binary operators it just checks that it's not equal to 0 if it's an integer. And so we loop through, so this is for 4 bits, we count the number of times where we can AND it with the 1, and then we add that to our count, and at the end we return the count. So you see, count X, it's counted 1, and it's just been this one here, or it's been a 4. Another way we could do that is if we take this, which is now going to be a 1 or a 0, and then we shift it back I bits, which is also going to give us 1, and this is quite nice. And you can see here we've got 1, 2, 3, 4, 5, but when we count Y, it's not going to count them all because this is longer than 4 bits. So we could change this so that it's just a larger number, so if we make it 8, and then we can count that Y has 1, 2, 3, 4, 5 ones. If we wanted to generalize this, we could take the log base 2 of our number, or we could keep going while there's still some bits left in the number, but we'll just leave it as 8-bit numbers. Another way you could do it is if you take this string, convert it into a string, and then count the number of ones, and you can do that both ways, and that also counts them, although I think our way is a lot nicer and it's a lot more efficient when you write stuff to yourself. This is a different one, and it works out if you've got an even or an odd number of ones, and it returns a 0 or a 1. And so what we do here is we do the same, but this time we XOR it, and it'll be nice to keep this rather than the single line if statement, because I think that looks a lot nicer. So we take our number and then we XOR it. So if it's a 0, it becomes a 1, and if it's a 1, it becomes a 0. So it oscillates between an even and odd state, and then tells you at the end. Kind of strangely though, it will return whether it's odd. So we might want to set that to be a 1. So now this one is even, and this one isn't even, so it's got a 0. Another thing that's nice is that you can use masks. So in this example, we're basically ORing with 4 1s and then 4 0s, and ANDing with 4 0s and 4 1s. And you can see that in the OR case, it set the start bits all to be 1s, whereas in the AND case, it set them all to be 0s, so it hasn't displayed them. But this means if we wanted to check if two numbers had a similar end, we could, mask the start, so just take the last 4 bits, because we're in essence chopping off everything before that, because it'll be ANDed with a 0 and it'll be a 0. If we XOR them together and there's a 0 there, then we want to return a 1, but if there is something, then they're not similar at the end. And now we can kind of put it all together and create this bin function, and we've set a length, but that's not necessary. And so what we do is we loop through and we put a 1 if we AND them together. Of course we could make this a string of this shifted backwards, but in this case it's probably better to use this. And we loop through and we put in a 1 if when we check that individual bit is a 1, otherwise we put in a 0, and we do it for length. And then we reverse it because it's gone kind of backwards through it, although we could kind of go backwards through length. And then we join them, and our joining character is 2 lines. And so we can just check that works by converting 25 into binary, which has worked. Hopefully you've enjoyed this video. You've learned a lot about bitwise operators, which are very useful for speed as well as in other languages, and you've seen that they can be very powerful. So see you again same time next week. Till then.